Let's talk about LED edge-lit acrylic signs. Anyone who knows woodworking knows there is no right or wrong way to make any project. It's simply a matter of personal preference. I'm Dave in Antwerp. This is the way I prefer to make LED edge-lit acrylic signs. I developed this really cool LED sign quite unintentionally. Several people in the CNC Router Tips group on Facebook had posted helpful how-to directions for making bases for the signs. I studied their techniques, but I wanted to solve three problems. 1. How to keep the acrylic far enough from the lights to avoid hot spots. 2. How to install a lighted switch in the sign base. And 3. How to use that extra 4 inches remaining in the 12 by 12 inch sheets of acrylic I had ordered. This style of lighted acrylic sign evolved from solving those three problems. These signs are not difficult to make, but I probably do it the hard way, judging from the amount of time it takes me and the number of components I use. The important thing is that I'm happy with the results. I hope you are too. I would like to thank Jim Sinicola and Charles Ireland for taking a road trip to help make this video. Jim Sinicola did most of the photography. Regardless of what we accomplished, it's always a good day when three old guys get to hang out in the wood shop together. We chose to make a sign featuring our home state of Michigan. We used Vectric software, VCarve Pro or Aspire. Jim uses VCarve Pro, Charlie uses Aspire. Either will work. This project is done exactly the same way in both VCarve Pro and Aspire. Let's start by looking at some of the parts and components. This video does not provide specific dimensions. Each sign builder will need to determine their own dimensions based on the components they use, the thickness of their acrylic, and their personal preference. I start making the base with a piece of lumber 3/4 to 1 inch thick. I cut two parts on the CNC. The upper part will hold the acrylic and a switch. The lower part will hold the LED lights and the wiring. Then I cut an insert from 1/4 inch plywood. The insert will be glued into the base and the LED strip will be glued onto the insert. Next I engrave a design onto the acrylic sheet. That leaves an extra 4 inches on the 12 by 12 acrylic sheet, enough to make a lighted insert for the center of the base. I cut out the sign and the lighted insert with a 1/8 inch end mill. I sand off the tabs and smooth the edge with 120 grit sandpaper followed by 220. I like a sanded edge on acrylic because it reflects light, making a nice border for the sign. The tan color you see is sticky paper that comes on both sides of the acrylic sheet. The front paper has been removed for engraving and cutting on the CNC. I keep a supply of pre-finished base parts and acrylic inserts on hand so I can put together a base quickly. I can cut off a short length of LED strip and wire a base during the time the acrylic is being engraved and cut. I usually make bases from cherry or walnut, but I have used other woods as well. I finish the wood bases by applying 2 or 3 coats of oil-based polyurethane, sanding lightly with 220 grit sandpaper between coats. After the final coat, I sand very lightly with 1500 grit wet dry sandpaper. Sometimes I use a wood that's not such great quality. Then I use a spray can of hammered paint to give a different look. The Michigan design for this sign was engraved with a diamond drag bit purchased on eBay. The engraving tool path you see here is for illustration purposes only. The vectors will be reversed before actually engraving the sign. The Quick Engrave Toolpath tab shows a 90-degree bit with a 0.01 inch tip. Depth or pressure is set at 0.03 inches. Step over is set at 50% of the tip width, which is 0.005 inches. The hatch angle is 35 degrees. Oops, disregard the incorrect decimal place in the photo if you notice it. While engraving, the router or spindle is not running. The shop is nice and quiet. On my computer, I need to make an adjustment when I run the Quick Engrave toolpath. Not everyone needs to do this. I go into the Mach 3 menu under Config to find motor tuning and increase the acceleration rate up to 20 for each axis. If I forget, I won't get clean edges on the engraved design. When I'm done engraving, I go back into the Mach 3 menu under Config and Motor Tuning and decrease the acceleration rate back to 12 for wood. You may not need to do this, but if you are not getting clean edges, you might want to look at acceleration and feed rate. In the tool library, the diamond drag bit is set up in the engraving section. I set the bit diameter at 0.01 inch with an angle of 90 degrees. The line width is also 0.01 inch. Step over is 50% or 0.005 inch. Spindle speed doesn't matter since it's not even running. All the spindle or router does is hold the bit. My normal feed rate for wood is 100 inches per minute. When I engrave acrylic, I run the feed rate at half speed, or 50 inches per minute for me. Optimum feed rates will vary for different CNCs. You should experiment to find out what feed rate gives you the best result. This preview sketch illustrates the normal way we would expect a workpiece to be carved. You need to use your imagination since we are working with a clear acrylic workpiece rather than wood, but clear doesn't show up well for illustration purposes. The tool paths are displayed on the right-hand side of the image. When I engrave an acrylic sign, I like the engraving to be on the back of the sign so the front is absolutely flat. Therefore, I flip the vectors horizontally about the center for engraving. There's no rule that it must be done this way. It just adds to the wow factor when people touch the sign and it's flat on the front. They ask, "How did you do that?" I explain, "It's magic." If you flip the image, though, don't forget to recalculate the tool paths and save them. This screen capture shows what the wood base parts will look like. The top piece in the picture will be the bottom piece of the base. It will have a large cutout in the center, where the plywood insert goes and where the LED strip will be placed. It also has holes for screws and a bump out for the switch. The bottom piece in the picture will be the top of the base. It has a slot for the acrylic sign and a hole for the switch. These profile tool paths will be cut with a 1/4 inch end mill. This shows the tool paths for making holes in the acrylic insert. There are 4 smaller holes for screws to pass through to fasten the top and bottom of the base together, and a larger hole to accommodate the switch and the wires. Here we are looking at profile tool paths to cut out the sign and the lighted insert from the acrylic sheet. I use a 1/8 inch end mill for these cuts. You can see where the tabs are. I generally set 3D tabs 0.35 inches long and 0.125 inches high. After cutting, I saw the tabs with a small fine-tooth saw rather than break the tabs off. When setting up a tool path, I go into node editing mode and set Make Start Point for each vector in an inconspicuous place, on the bottom of the sign and the back side of the base. The end mill generally leaves a mark on the workpiece at the starting point. I would rather have that mark where it isn't going to show as much. Here we see a screenshot showing the entire project folder for the Michigan sign. There are 3 Aspire files for the wood base, plywood insert, and acrylic sign. If you use VCarve Pro, those files will display the VCarve Pro symbol instead of the Aspire symbol. Then there are 3 tool paths for acrylic engraving and cutout, and there are 3 tool paths for the wood base. There are 2 tool paths for the plywood insert. Now let's talk about lights, wires, and components. Jim and Charlie and I laid out a bunch of the wiring components and assembly tools to get an idea how involved this project is going to be. That's a lot of stuff. Later we found that we needed to bring out even more tools as we worked through the project. Here the parts of the wood base are laid out side by side, ready for assembly. These are some of the electrical components and tools we'll be using. A reel of LED lights on a strip, a 12-volt 1 amp power supply adapter, or wall wart as it is commonly called, a switch, spade connectors to attach wires to the switch, a roll of 22 gauge speaker wire, alligator leads for testing the lights before assembling the sign, wire strippers and cutters, soldering iron, solder, long nose pliers, and a crimping tool. We will be using cast acrylic. Cast acrylic is generally preferred over extruded acrylic due to its enhanced refractive properties. My sign bases are designed for 3/8 inch acrylic. Some people use a 1/4 inch, some people use a 1/2 inch. This sign and base insert are cut from a 12 by 12 inch sheet of cast acrylic ordered from E Street Plastics online. Although large sheets might be more economical, I like the convenience of getting sheets cut to size and delivered to my door. To engrave the sign, the first step is to remove the sticky paper from one side of the acrylic and mount the acrylic on the CNC table. The hold downs are there to prevent lateral movement. We don't need to worry about the acrylic lifting off the table because we are using a diamond drag bit. The shop is quiet while engraving. The router is not turned on. The bit simply scratches back and forth across the acrylic to create the colored portions of the sign. Next, we cut out the sign in the acrylic insert using a 1/8 inch flat nose end mill. It's a solid carbide 2-flute end mill made in China, purchased on eBay in a box of 10 bits for about $10, and it ships for free. This cheap bit will cut quite a few acrylic signs before getting dull. Then we toss it out and use a new one. I use these inexpensive 1/8 inch end mills for lots of projects in wood, acrylic, and Corian. One big question is always, what power supply to use? Some reels of LED lights ship with a great big transformer. You don't need it. This is the power supply I use, a 12 volt 1 amp power supply adapter, commonly called a wall wart. Each sign requires only a fraction of an amp, so this power supply is perfectly adequate. If I were to daisy chain a half dozen signs together, I may need to move up to a 12 volt 2 amp power supply. These 12 volt 1 amp power supply adapters are very cheap on eBay, and there are lots of sellers. I find the cheapest one with free shipping and order them in lots of 20 at a time. The power supply has a male barrel plug. Next to the male barrel plug in the photo is a female barrel plug with a wire attached. This is called a pigtail. The pigtail is what attaches to the LED light strip. When the wall wart is plugged in and connected to the pigtail, the sign lights up. The pigtail attaches to the wires coming from inside the sign. Shrink wrap insulation keeps the wires from touching each other and neatly wraps up the whole connection. Shrink wrap insulation comes in two common ratios. With the application of a heat gun, 2:1 shrink wrap reduces down significantly, while 3:1 shrink wrap reduces down even more. I'll show you in a moment what I'm experimenting with in the hope of eliminating exterior wire connections. I like a lighted switch on my signs, but LED signs do not need a switch. And if a switch is used, it does not need to be lighted. There are remote control switches that can be wired into the circuit if desired. These remote control switches can either be infrared, meaning line of sight, or RF, which means they operate wirelessly up to 90 feet away through walls and doors. If you haven't worked with LED light strips before, it would be a good idea to learn how to connect them. There are wireless connectors available on eBay, but I have found that wireless connectors are not reliable. I solder the wires to copper tabs on the LED strips. It is not difficult. YouTube has a lot of good videos that show how to solder LED light strips. LED light strips generally come on a reel. You can learn about the differences between various types of LED lights by watching YouTube videos and reading informational materials from websites. You can purchase reels of LED lights on eBay, Amazon, or pick them up at hobby shops. With regard to quality differences among the various brands of lights, I have learned that 1. The adhesive strip won't stick very long no matter what brand you get, and 2. Most brands of LED strips work just fine. When you go to purchase light strips, you will often see the designations 5050 SMD or 3528 SMD. The numbers refer to the size of the LED chips. A 5050 chip is larger in physical size, so it emits more light. It is brighter. A 3528 chip is smaller, so it emits less light. It is not as bright. The letters SMD are an abbreviation for surface mounted diode. LED is an abbreviation for light emitting diode. Individual LEDs can be mounted just about anywhere. SMD means the chip is mounted on the surface, in this case on a strip. You may see the term high density. That means an LED strip that has twice the normal number of chips in the same length, so it is brighter. I find that normal 5050 SMD LED strips work just fine for my signs, so I have not used high density strips. You will have the choice of buying waterproof or non-waterproof LED strips. I always use waterproof. Waterproof LED strips have a layer of heavy plastic over the strip to protect the chips and the resistors that are mounted on the surface of the strip. Non-waterproof LED strips do not have that protective layer. They are more easily damaged if they come in contact with something. Many people like to position the acrylic sign right on the waterproof strips. The lights won't get damaged because of the heavy layer of plastic. After cutting off an appropriate length of LED light strip from the reel, the first thing I do is test it. I clip alligator leads to the copper contacts on the strip and then connect the other end to the pigtail. Then I plug the power supply into the pigtail. The LED light strip should light up. I don't want to assemble the LED sign until I know it works. To assemble the base, the first thing I do is glue the switch into the hole. I use a couple small dots of CA glue right on the edge of the hole. Then I press the switch into the hole. The lighted switches I use are actually made for metal panels, so they have tabs on the side. I cut off those tabs before gluing the switch into the hole on the top of the base. Next, I strip a small amount of insulation from the ends of the wires and tin the stranded copper with solder to keep it from fraying. To hold wires for tinning and soldering, I glued some old spring-type clothespins onto a piece of scrap wood. The clothespins hold the wires and LED strips flat in the right position for soldering. To connect the switch, I crimp spade connectors onto the ends of the wires using the crimping tool. These spade connectors press onto the tabs of the switch. The switch has 2 silver tabs and a brass tab. A red wire goes onto each silver tab and a black wire goes onto the brass tab. Next, I route the wires from the switch through the hole in the acrylic insert. From this point forward, the acrylic insert and the top of the base remain next to each other so the wires don't end up in the wrong place. Then I prepare the LED strip. The first thing to do is to cut it to the correct length. Every 2 inches or so, the LED strip will have a line drawn across the copper solder tabs. Usually there is a small illustration of scissors next to the line. Do not cut the strip anywhere but the line. To prepare the LED strip for soldering, the heavy plastic waterproofing layer must be peeled off the end of the strip, exposing the copper solder tabs. YouTube has some excellent videos showing how to solder LED strip lights. These videos will show how to peel the plastic away, exposing the copper. The copper tabs on the LED strip and the ends of the stranded wire should be tinned with solder before soldering. Tinning keeps the wires from fraying and makes a quick solder connection, helping to prevent the LED strip from overheating or melting. Before soldering the wires to the LED strip, slide a length of heat shrink insulating tube over the wires. Then solder the wires to the copper tabs. The red wire goes on the tab marked plus and the black wire goes on the tab marked minus. When the solder has cooled, slide the heat shrink insulating tube over the end of the LED strip until it just touches the first LED chip. Then use a heat gun to shrink the insulating tube over the soldered connection. I drill a 1/4 inch hole in the rear wall of the bottom section of the wood base near the end with a switch. This is to allow access for inside wires to be connected to the pigtail outside the base, which will then be plugged into the wall wart. Clear plastic aquarium tube makes a good flexible conduit inside the end of the base. The wires from the switch go through the end. A diamond shape is cut in the center of the tube to allow wires from the LED strip to enter the tube. I then route all the wires through the aquarium tube to the hole drilled in the outside wall of the base. The plywood insert is pressed into the bottom of the wood base and hot glued. When I first started hot gluing inserts into bases, the hot glue didn't stick very well. I discovered that some glue sticks are made for plastic and wood, while others are made for paper and other materials. For working on sign bases, the hot glue sticks made for wood and plastic work great. Before I apply finish to the wood base, I countersink the holes for the screws that fasten the bottom part of the base to the top part. The screws and the plywood insert will be flush with the bottom of the wood base. With the plywood insert fastened into the wood base, it's time to glue the LED strip onto the plywood insert. The self-adhesive tape on the LED strip usually does not hold very long. I remove the backing from the bottom of the LED strip and glue it down with CA glue. Sometimes I need to apply a quick shot of CA glue activator. Now it's time to double check that all wires are routed through their respective holes and through the aquarium tube correctly, and then tuck the aquarium tube inside the end of the base. At this point, the parts of the base should all be positioned correctly. Before final assembly, it's a good idea to test the sign to be sure it's working. When all the wires have been tinned, including the pigtail wires, I solder the wires together in the proper sequence. One nice thing about working with 12-volt LED lights is that if you make a mistake, nothing bad happens. No shocks, no smoke, no explosions. The LED strip simply doesn't light up. Then you connect them in a different manner until the LED strip does light up. I slide shrink wrap insulation tubes over the wires. After soldering each connection, I shrink the tube with a heat gun. The last tube is the largest. It goes over all the connections, making a nice neat cable. At this point, the base should be clamped together, carefully avoiding dents in the base, so that number 8 assembly screws can be driven in from the bottom. Now that the base is complete, it's time to prepare the acrylic sign itself. The acrylic has already been engraved, cut out, and edge sanded at the beginning of the project. Now we can wash the sign in the kitchen sink. I like to wear gloves so I don't get fingerprints all over the newly washed sign. I wash it in ivory dish soap, which contains no lotions or dyes to get on the acrylic. After drying the sign gently with a soft terry cloth towel, I take the acrylic sign back out to the shop for polishing. Still wearing gloves, I clean the sign again using plastic headlight cleaner applied with a soft knit cloth to both sides of the sign. I cut up old white t-shirts for this. I follow directions on the bottle, wiping and buffing to a nice shine. This removes small surface scratches. Then I polish the acrylic with Novus plastic polish. I get mine from E Street Plastics along with my acrylic sheet, but Novus plastic polish can also be purchased from Amazon and other sources. Again, I apply the Novus polish with a soft knit cloth. I rub the acrylic vigorously on both sides to remove any remaining fine scratches and then buff to a nice shine. With the acrylic clean and polished, still wearing gloves, I wrap the bottom 3/4 inch of the sign with black vinyl electrical tape. This directs light into the sign and provides a snug fit in the wood base. I make my signs removable for 2 reasons. First, removal makes the sign easy to clean. The first thing everybody does is touch the sign. Cleaning off fingerprints is easier when the sign is removed. Second, a second sign or a third sign can be put into the same base. My grandson figured this out right away. He asked, could we take out the soccer sign and put in a basketball sign? Now he is thinking about a baseball sign. I wrap as much tape around the bottom of the sign as I think it will need. If it's still loose in the base, I add another layer or 2. If it's tight, I remove a layer of tape. Now all that is left to do is place the acrylic sign into the wooden base and plug in the power supply. If we have done everything correctly, the sign will light up nice and bright and it will get a lot of oohs and ahs. Again, I would like to thank Jim Sinicola and Charlie Ireland for making a road trip across the state of Michigan to help me make this video. Jim Sinicola took most of the pictures. Thank you guys.